Alright, today is Thursday, August 20th. This is Module 1, Day 4. Yesterday we left off with looking at some special right triangles, so I just want to recap that. I remember in a 30, 60, 90, going from a long leg to a short leg, I'm going to divide by the square root of 3. But I cannot leave it that way, so that becomes 40 square roots of 3 over 3. So that's x. Then going from the short leg to the long leg, I'm going to multiply the short leg times 2. So 40 square roots of 3 over 3 times 2 over 1 gives me r to equal 80 square roots of 3 over 3. So here's x and here's r. For a 45, 45, 90, remember that we're going from the leg, which is also the same down here, to the hypotenuse. So that will be 2 square roots of 8, and we're going to multiply it by the square root of 2. That gives me 2 square roots of 16. I always want to check to see if I can simplify that radical, which it can. So that's 2 times 4, which is 8. So r is 8, and x is 2 square roots of 8. And so there was a few of those in your homework as well. Again, a lot of this is just practicing with exact values and simplifying radicals. Okay, the other thing to talk about today are the cofunctions. The cofunctions, these identities, you won't really fully understand them until we start graphing. But just to kind of give you an idea of why and how, we're going to take this triangle right here and we're going to fill in all of these ratios. So like theta right here, standing at theta, the sine would be y over r, cosine would be x over r, tangent would be y over x, cosecant is r over y, secant is r over x, cotangent is x over y. And then for beta, we're now going to stand at beta and find all of those ratios as well. So the sine will be x over r, cosine will be y over r, tangent will be x over y, cosecant will be r over x, secant will be r over y, and cotangent will be y over x. The next thing I want to do is I want you to see the correlations here. So if you draw a line to match these up, sine of theta and cosine of beta, they're both y over r. And so we're going to go through and just match them all up. My tangents and cotangents match this way. And then my cosecants and secants match. Okay, so what I'm going to do right here is I'm going to write this out, that the sine of theta is equal to the cosine of beta. And I'm going to write the rest of these down here. So you can pause it, fill them in, and then I'll pick up. Okay, so I went ahead and filled them all in. Here's one thing to think about. If this is a right triangle, okay, then these two angles have to add to equal 90. So if I'm given theta, then to find beta, I'm going to take 90 and I'm going to subtract this angle theta. For instance, if this was 35 degrees, then I would take 90 and I would subtract 35 degrees to get beta. Well, what I'm going to do is I'm going to take this beta right here and I'm going to replace it with 90 minus theta. And by doing this for all of them, I will have my cofunction identities. Also keep in mind that 90 degrees is pi over 2. So any of these could be replaced with pi over 2. Meaning I could still have the sine of theta equal to the cosine of pi over 2 minus theta. And so it might help if you go ahead and fill these in also with your radians. Okay, dot, dot, dot. So keep those going. I would write them all on one page. For the sake of time, though, I'm going to keep going. All right, the other thing to talk about is using identities to simplify equations or to transform one side of the equation to the other. Where theta is between 0 and pi over 2, that just means we want all positives. All positives. Quadrant 1, x and y are both positive. Okay, so what is that asking? Well, it's saying that we take the hardest or complicated side and we want to make it look like the easy side. So the easy side is 1. So whatever I do on the left side, it's always going to equal 1. And then I use my identities to see if I can manipulate or transform things. So a lot of times I want to check to see if I can rewrite certain trig functions in terms of cosine or sine. I know that I have cosine times secant here. Well, I can also rewrite secant as 1 over cosine theta. And remember, that's already over 1. So when I go to multiply them, I get cosine of theta over cosine of theta. That also equals 1, and that becomes a 1. And so thus it is transformed, verified, checked. So here I used a reciprocal identity. For part B, I have two binomials multiplied together, so I'm going to use my algebra skills and I'm going to FOIL it out or distribute it out. So I get secant squared theta, negative secant theta tangent theta, plus secant theta tangent theta, minus tangent squared theta, and that equals 1. You'll notice the two binomials are exactly the same, except you have a positive and a negative, and that usually results in the middle term canceling out. So we've got secant squared theta minus tangent squared theta equal to 1. And then both of these are squared, so it makes me want to think about my Pythagorean identities. So remember our Pythagorean identities, we had that 1 plus tangent squared theta is equal to secant squared theta. Well, if I just subtract tangent squared theta, then I get 1 equals secant squared theta minus tangent squared theta. Remember we talked about how you might see those. So that means this right here is equal to 1 and 1 is equal to 1. Okay, so you're going to have a couple of those where you have to look at your identities, so keep those handy. The last thing for this section, 4.3, is a little bit of word problems. Just to recap, here is like a line of sight. An angle of elevation would be going north of that line of sight, and an angle of depression would be going south of that line of sight. So first off, I have a 30-meter line used to secure a helium-filled balloon to the ground. Because of a breeze, the line makes an angle of approximately 75 degrees with the ground. So here I have the string, there's a balloon, and then the height. The string is 30 meters, the angle is 75, and I'm looking for that height. That's going to be opposite, this will be hypotenuse, and this is back to the old school geometry of solving triangles. So that's going to be a sine of 75 degrees equal to x over 30. Multiply both sides by 30. Hey, don't forget to change the mode in your calculator. Remember, that's in degrees. So this leaves us with approximately, I believe it's 28.977. And it says 3 decimal places. Usually on word problems, we just kind of, it's about 29 feet. But it did specify. The next one is a surveyor standing 50 feet from the base of a large tree. There's a figure here. The surveyor measures the angle of elevation. So here's my angle of elevation right here, 71.5 degrees. The surveyor is 50 feet away from the tree, and we want to know the height of the tree. So that's going to be opposite, that's adjacent, so we'll use tangent of 71.5 degrees equal to y over 50. Multiply both sides by 50 here, and I end up with the height of the tree is approximately 149.434 feet. Okay, again, that's the old school geometry. There's a few of those for practice tonight. Okay, so your practice is page 281 to 282, 37 through 57. That's going to be looking at those cofunctions. Okay, 59 through 66 is going to be using the identities to transform. And 73 through 82 is going to be some word problems. Email me if you have any questions, even over yesterday's homework as well. All right, that's it.